Good evening and welcome back. In last lecture, we discussed about some basic properties of laser, then atom, electron, photon, how electron can move from lower orbital energy level to the higher orbital energy level, or how it can move from higher orbital energy level to the lower orbit, that we discussed in earlier lecture. Now today we are going to extend that topic and we are going to understand what is the difference between the ordinary light and laser, that we have to understand in today's lecture. Okay, 1 nanometer means what? 1 nanometer is the 1 billionth of a meter. It is 1 billionth times of a meter. Is nothing but 1 nanometer. Now a human hair is about 80,000 nanometer. 80,000 nanometer in diameter. That's about 115 times the wavelength of a red light. Means what? It means what? The wavelength of a red light is equal to the 115 times the wavelength of a red light. Means a human hair is 115 times than the wavelength of a red light. This is the very small as compared to the hair diameter of hair. Okay, so further move forward. The next point is light bulb. What are the basic properties or basic of a light bulb and laser? First we have to understand that light is not focused. It is made up with the help of many colors, and light is not a coherent. That are the main difference between the light source and laser source. In laser we are saying that a light is a highly monochromatic. It means what? It having only one wavelength. The light is a coherent and all the waves are exactly in phase with one another. Its divergence is zero. It's extremely intense as compared to this ordinary bulb. These are the main difference between the ordinary source and laser source. Okay, in case of light bulb, it is an ordinary source. It is not focused. It made up of many color, or it having number of many wavelength. Light is not a coherent. Okay, so white light means what? A light from a light bulb, it gives a white light. It means what? It consists all colors. That's why it is having more longer wavelengths, and it does not coherent, and it does not focus on a single point. Their divergence is more in case of ordinary source as compared to the laser source. Is not a coherent source. It having longer wavelengths, and it consists all the colors. Okay, If we move forward, then laser light. If we see this figure, you can observe that light is more focused. It is made up with the help of one color, and light is a coherent, very well focused, and it made up with the help of one color only, means monochromatic, coherent, and divergence is 0. These are the basic properties of laser light or laser source. Okay, do you understand the difference between the ordinary source and laser source? Okay, so let us start. And next point, or in case of laser light, laser light, it having only one wavelength, and it is a coherent source, and all light is focused on a single point, means crest is overlapped by another crest, trough overlap with another trough. Okay, means all the light is in phase, coherent. That's why it is called as a coherent source, monochromatic source, and well focused, or divergence is very less in case of laser light. So let us understand the difference between the ordinary light or monochromatic light, or a monochromatic light with coherent light, monochromatic and coherent. If you consider a ordinary light, it consists a number of wavelength. In case of monochromatic light consists a light with a single wavelength, but all the waves is not in phase. If that wave having monochromatic, it means single wavelength, as well as all are in phase, then that source is nothing but a monochromatic plus coherent light. If that source consists number of wavelength, it is ordinary light. If that source consists monochromatic light only, means having single wavelength but all the waves are not in phase. But if that source is monochromatic as well as coherent, it means what? They are in phase as well as that source having single wavelength. This is the main difference between the ordinary light, monochromatic light, and monochromatic plus coherent light. Okay, do you understand? So let us move forward. Now we are able to understand what is the difference between the ordinary source and laser source. Now we are going to move forward, and we have to understand the working principle of a laser. Or how does a laser works, that we have to understand. As we know, the output of a laser is a coherent electromagnetic field. In a coherent beam of electromagnetic energy, all the waves have the same frequency and same phase. A basic laser consists of a chamber known as the cavity, which is designed to reflect infrared, visible or ultraviolet waves. Okay, so that they reinforce each other. They reinforce with each others, and that cavity can contain either solids, liquids or gases. The choice of the cavity material determines the wavelength of the output. Which kind of material we are going to use in that cavity, it decides the wavelength of that output. So mirror are placed at each end of the cavity. One of the mirror is totally reflective, not allowing any of the energy to pass through them. The other mirror is partially reflective, allowing 5% of the energy to pass through them. Through a process of pumping, the energy is introduced into the cavity through an external source. How that we have to understand in optical pumping topic. Due to a pumping activity, an electromagnetic field appears inside the laser cavity at the natural frequency. At the natural frequency of the atom. So the waves are reflected back and forth between the mirrors. So the length of the cavity is such that the reflected waves reinforce each other. That's why the electromagnetic waves in phase with each other emerge from the end of the cavity having a partially reflective mirror. So what is the importance of that partially reflective mirror, that we have to understand? The output is continuous beam or a series of brief intense pulse. So if we see this figure, in this case, when electron is in a ground state having energy E1, that ground state electron absorb energy from photons having energy E is equal to h nu. When that ground based electron absorb that energy, it moves or it get excited and it moves to a higher energy level E2. It stay there for a very small time. When an electron moves from one orbital energy level to the higher orbital energy level, that is from E1 to E2, by absorbing a incident photon E is equal to h nu. That kind of phenomenon is nothing but a absorption. So once that electron reach to a higher orbital energy level E2, it emits, it stay there for some small time. After that, it emits energy in the form of photon is equal to h nu, and it come back to a lower orbital energy level E1 to become a more stable. Okay. And if we take the energy difference between higher orbital energy level to the lower orbital level E2 minus E1 is equal to h nu. E2 minus E1 is nothing but h nu. Okay. Next, the stimulated emission. In that case, one photon get absorbed by the electron of higher orbit. When it moves from E2 to E1, in that case it emits two photons. Okay, these are some basic concepts or working principles of laser. One is absorption phenomena, spontaneous emission, and stimulated emission. Now these phenomena we have to understand one by one. One by one. So first one is the induced absorption or stimulated absorption. Stimulated absorption. So in this case, if a photon of energy h nu collides with an atom present in the ground state of energy level E1, present in the ground state of energy E1, then the atom completely absorbs that incident photon and make transition to a excited state, and it moves to a excited state by absorbing a incident photon. That's why if you take the energy difference between the E2 minus E1 or the higher orbital energy level to the lower orbital energy level, it gives the energy which is equal to the incident photon. So the process in which an atom sized system in lower energy state is raised into a higher energy state by electromagnetic radiations, which is quanta of energy is equal to the difference of energy of the two states, is called stimulated absorption. It's called a stimulated absorption. H nu is equal to E2 minus E1. Okay, do you understand? If you have any doubt related with the stimulated absorption, spontaneous emission, stimulated emission, and difference between the ordinary light, monochromatic light, and so these are the main difference between the ordinary light, monochromatic plus coherent light. After this working principle, we move to a stimulated absorption. If you have any doubt related with all these concepts, you can ask me in comment section. The remaining part of this lecture will continue after one break. Thank you.